Hello, my name is Muqeet Iqbal and I'm a postdoc at University of Orléans. I did my PhD at University of Rennes before, where I looked at the mechanisms which are controlling the mobility and the retention of colloids. So what are colloids? Colloids are ubiquitous in nature. They are very small particles which can be vectors of contaminants in porous media. So for example, in my poster I talk about emerging contaminants which are rare earth elements, and the colloids, for example organic matter and organic matter combined with iron oxides can really transport these contaminants. So how we can look at the mobility of these contaminants? So for that I conducted my column experiments in which I inject my rare earth element solutions without colloids to have a blank test, and we can see that the mobility of these rare earth elements without colloids is very low. This can be seen by the breakthrough curves. On the other hand, when we inject colloids together with rare earth elements, we see that the mobility of my rare earth elements is enhanced drastically. This we can see by reduction in the amount of time needed for these metals to break through. So we try to explain this process at a continuum scale without colloids, and we can combine surface complexation parameters with advection dispersion equation to describe these parameters, to describe this process with all the rare earth elements together with scandium, yttrium, thorium and uranium. However, when I try to predict the transport of these rare earth elements with colloids, this didn't prove to be a very successful exercise at the continuum scale. So in order to look at their transport at the pore scale, we are looking at wettability alterations and pore clogging caused by colloids in the porous media. So in order to look at these processes, what I'm doing now in my postdoc is I'm conducting X-ray microtomography. So I rotate my column and I collect pictures at different angles, and I reconstruct my 3D images. So we do that in order to develop reference data sets for in order to validate the column scale studies. So if you would like to know more, you are more than welcome to connect with me on LinkedIn, and I'll be happy to have a talk with you. Thank you.